Hello, welcome to Click 14. This is the 14th video in the Click PLC programming tutorial that I'm doing. Today, what we'll be looking at specifically is the send and receive commands. I'm going to show you how simple they are to use, how simple it is to send data to one PLC and receive data back. For this setup, we have one master PLC set up, and we have two slave PLCs set up, all of them using the Modbus protocol with port 3. RS-485 communications. You will see how simple this is to wire, how simple this is to program, and with this you'll get the idea of the concept of having one PLC collecting data from remote locations. Now this is just going to be hardwired together with three PLCs connected. In the next video we'll expand out what we have on this one to show radio communications in addition to the existing two PLCs that we'll be having as slaves. So if you like these videos, please give me a like and please subscribe. It really helps keep it going. So with all that, let's get started. All right, in this example here, this is my Click 14 program. It's just a little simple program I've made for this video. Let's start with the rung number 2 here, where I have a receive command set up. Clicking on it, come up, and you can see that I've got a lot of information here. The receiving data setup is grouped together. The status flags are grouped together. But up here at the top, I have the COM port, the protocol, and the COM port setup. Now I can access the COM port setup right here, cancel, or I can access it from over here under, let me close this completely, or I can access it over here at the COM port setup. It's the same thing, comes up exactly the same. So the first thing I want to do is make sure my COM port is set up, because I can't do any communications unless I go through the COM port. Now the default is always going to be port 2 when you go to set up a send or receive or whatever. Now port 2 will use your RS-232 communications and not your RS-485. Now remember, our PLC, if I click back to port 3, has one of these on there. It has the third port with a RS-485, and that's what we'll be using for the communications. Looking back at port 2, this is what we have. This uses an RJ12 phone jack. It's a 6-pin connection, but the biggest thing is it's RS-232. Now RS-232 has a physical limitation of 50 feet for the total length of the wire. That means the device that you're communicating with can be up to 50 feet away. And the other limitation is it can only connect to one device. So if it's connected to one device and it's within 50 feet, it will work. But if you start to go out more than 50 feet, you're risking getting some poor communications, static built in, and so forth. Let's look at port 3. Port 3 is RS-485. Now it's a 2-wire connection. Now this is also showing the line ground, but in the sample that we're setting up, I'm just using the plus and the minus, and the plus is the red wire, the minus is the white wire, but the distance is that you can have this going over the full length from one device to the furthest device away is 4,000 feet. That's 1,200 meters, or say about 13 football fields end to end. That's quite a ways away that you can have this, and it doesn't require really special wiring and so forth. So this makes it very, very convenient, very easy to use. Oh, also the number of devices, you can have this connected to, I believe it's 32 slave devices and a driver at the same time. So that means if you're using one master, you can have 32 slaves out there operating it, that it's reading and writing information to and from at the same time. Now if you look at the addressing over here, this COM port setup is for the PLC that I'm connected to now. This is our master PLC. This is the program I'm using for the master PLC, and it's always going to be number 1. That's what I choose, is I choose number 1 because to me it just makes more sense. I'm taking the default baud rates, and with the odd parity and the stop bit, they're all exactly the same. Now here's the big thing. Every one that you connect to, every device that you connect to, must be set up exactly the same on the baud rate, the parity, and the stop bit. They have to be set up exactly the same, or they're not going to talk. Looking into the receiving command itself, You can see I have the port is the same. All my COM port setup is exactly the same. Click on it, you can see I have not changed anything in that. Now, for the receiving data setup, this is naming the device. This will be device 11, node address 11, slave 11. That's going to be the second PLC that I've got connected there. And what I'm going to do is I'm going to read some information. With a Modbus function code of 03, 03 is read holding registers. These are the choices that I have for reading. I can read an individual coil status. Say, for example, I wanted to read C22 to know is this pump running or not. Or I could read input status. Holding registers is what I want to look at though, and these are whole words. So now the addressing, I could use, let me click on this again. I could use the Modbus 984 addressing, but we're already used to using the click addressing, and besides that, we're only talking a click to a click anyway, so it makes it easy. So instead of using some big long number, I can just use the addresses that we're used to using. Slave 11 and node 11, I have some data words set up, DS 1, 2, 3, 4, and 5. And so what I want to do is, starting in that address is where I want to collect my data from or receive the data from. And what I want to do is I want to take it into the master, which is this PLC, and I want to put it in DS 111. Now, how many words am I going to get, or how many registers? I'm going to get 5. So that means I'll be pulling data in. I'll be getting data from DS 1, 2, 3, 4, and 5 in this node 11, and I'll be bringing it back in to my master node at node 1 and to DS 111, 112, 113, 114, and 115. That's 5 words. Now the word swap is something we can discuss a little bit later. And now for the status flags. I want to know when it's receiving, whether it was successful or not, and whether there was an error. And if there was an error, I want it to give me a code representing that error. I want it put in my status word, DS11. The reason for 11, because it's real simple. This is the error code that came from node 11. All right, so that's what this is all about. Now then, you'll see I have another receive over here. This receive is exactly the same as the other one, the only difference being that now I'm getting it from node 12. I'm getting it from their same address, DS 1, 2, 3, 4, and 5. But in the master, I'm putting it in DS 121, 122, 123, 124, and 125. And my receiving status flags are just the next group of numbers and words up. So that's all there is. Now then, I also have 2 send commands here. Now notice all these two, I'm also using port 3, but I'm using this bit right here. Let me back up a little bit higher here. Up here on the first line, I've got a 60-second timer. And what I'm saying is, when this reaches 10 seconds, I want it to do this one. When it reaches 20 seconds, I want it to do this one. That way I don't have any clashes going on and so forth. I've got 10 seconds between one and the other. Now there's some other ways also to be sure that you can go from one device to the next device to the next device using the same COM port without having conflicting commands through the same port at the same time. Because you give this right here with maybe the leading edge of this contact right here, say it's just as the leading edge has gotten to 20 seconds. Well, what if it takes a second and a half or 2 seconds for this to complete, or 15 seconds maybe for this to complete? In that time, this port is being active, and you don't want the next port, you don't want the next command to try and use the same port because this port's already active, port number 3. And since we only have one port, we need to make sure that we're only using one command with that port at a time. Now, getting back to the send. Now this time, this is almost exactly the same as what we have on the receive. The biggest difference is now we're writing multiple registers. Instead of instead of reading multiple registers, we're writing multiple registers. How many registers are we going to write? I'm only going to write 4. And I'm beginning to write that in the slave address of DS2. And the reason I'm not starting in the first word, DS1, like I'm doing the receive, is because in DS1 I have the node address in the slave unit, so that when I pull data back in, I always know it came from the correct slave unit. And where I'm going to get this information from, I'm going to get this one from DS116. Now, you remember when I was receiving from node 11, I was putting it in DS111, and I was putting 5 words in there, DS111 to DS115. Now then, I've got some data that I want to write into that, starting at DS116, and I'm going to send 4 words over there. What this is going to do, it's going to allow me to send some information from here, from my master, to the slave unit, and then read the information that that's in the slave unit back into the master. When that is working correctly, then I'll know that I'm sending data and receiving data, and it's talking back and forth just like it should. Now, we still have the same type of status flags. The only difference is the first status flag, instead of being receiving, it says sending. Other than that, everything is the same. That takes care of that right there. Now we can take a look at what we have in the hardware. Well, this is the setup. This is the master power supply. I'm connected in right now to the master. You see this right here? That's the master connection. This is node 11. I put a label on it. Going across, this is node 12. Now you'll notice the only things here are just the power supply and the Modbus. I have no other information on these at all. So in the programs, it's just like what we looked at. I'm just taking those 5 addresses in these two, DS1, 2, 3, 4, and 5, putting in the data that I want in there, and then over here on the master, I'm looking to see if this data is actually coming over. Now let's take a look at the program. All right, let's take a look real quick at what we have in the slave units. I'll go down to slave 11. I'll call this Click 1411 because it's slave 11. And this is what I put in the program. First rung, all I'm doing is I'm putting the value of 11 into DS1. That's my node number, or my node name, node address. And number 2, I'm taking the real-time clock hour, whatever that happens to be, and I'm putting that value into DS2. Let me scoot down just a little bit. On a DS3, I'm doing the minute, adding the minute into DS3. And on rung 4s and 5, I'm just putting in values 11,001 into DS4, 11,002 into DS5. That's all it is. I don't have anything else in this program. I'm just making sure that I have some data that I can read and make sure that the data is correct and in those addresses DS1 through DS5. The other important thing is, if I go over here to function, COM port 3, you'll see my COM port 3 is set up exactly correct. It's set up exactly the same as what I had before, except now this is my node address for the slave. This is 11. My baud rate, parity, and stop bits are the same. That's all I have to do to set this up. Now it's ready to receive commands and to have commands sent to it. That's all there is to it. It's so simple. Let's take a look now at the next program for the next slave unit. No, I don't want to make any changes. All right, this one's set up exactly the same as what I have before. In DS1, I have a value of 12, and then the real-time clock hour and minute. And then for DS4 and 5, I'm putting 12,001 and 12,002. This is node 12. So now if I go back over to the COM port on this, you can see it's exactly the same as the last one we just looked at, node 11. The only difference is the node address now is 12 instead of 11. Now remember, these are slaves. Slaves do not initiate communications. All communications initiated are coming from the master. Up here, just for a quick glance in the address picker, if I go to my DS words, you can see that I'll label these as node, hour, minute, value 1, and value 2. Let's go ahead and look back at slave 11 real quick. You know, like I said, on rung 1, I'm just putting in the node address, and this is happening every scan. And the same thing with the real-time clock hour, the real-time clock minute. and that takes care of DS 1, 2, and 3 in the slave. But now on DS 4 and 5, if you'll notice, I put in a first scan bit here for each. This bit is closed only on the first scan when the PLC is just turned on. So let's take a look real quick at the address picker. Going down to the system bits, SC. Now we also have system words, which is we keep up with values like the real-time clock and so forth. But this is the system bits. Now the first bit is always on. The second, SC2, is the first scan. It's only closed on the first scan. It's only energized on the first scan. And then we get some other bits too. This is when the clock hits 10 milliseconds, 100 milliseconds. So we can use these also for just timers if we wanted to. If we wanted something to happen, say every 10 milliseconds or every second or every minute or every hour, those bits are already in there. But if we scroll on down a little bit, you see there's quite a few that are in there. Okay, now we come up to this area here. 100 is port 2 ready flag. 101 is port 2 error flag. And we have the same thing for port 3. So we always know when port 3 is ready. That means it's not being used by another command, and it's ready for a command to be sent to it. And also this would let us know if there's an error on it at the time. We have those bits available. So what I've done here is I've taken the first scan bit, SC2, and I've put it in on rung 4 and 5. And that means this value, 11001 and 11002, they will only be written into DS4 and DS5 when the PLC is just turned on the first scan. So now I did not put this in on number 12. So number 12, whatever values that I send to write into these values here will never show up. Every scan of the slave will write these values into these DS values. So that one would always have, number 12 would always have a 12001 going into DS4 and a 12002 going into DS5 on slave 12. Now let's go back to the master. Now in this timer that I've got it set at 21 seconds. At 5 seconds, we're going to do a receive through port 3 to slave 11. At 10 seconds, we will do, come down, scroll up a little bit. At 10 seconds, we will do a receive from slave 12. At 15 seconds, we will do a send to slave 11. Scroll up one more time here. At 20 seconds, we will do a send to slave 12. Going into the data view, you can see what I've got here. Let me move it up a little bit. These are the current values that I'm reading right now because this is working. You see the successes showing over here. This is what I'm receiving right now from slave 11. This is what I'm sending right now to slave 11. So you can see right now it has a 7 in there. But if I take slave 11, I'm manually turning it off right now. And now I'm going to turn it back on. So when it does the first scan, you can see these values immediately went to the value that I had set up for the first scan, 11001 and 11002. And now I'll do a send, and then when I do a send, these values will come over, and on my next read, you will see these values change. Now we're only doing this every 5 seconds, so we have 4 to do, so it's 20-second cycles. So here you can see it just changed to 7 and 8. Now I'm going to write in on the values that we're going to send, DS118 and DS119, I'm going to write in a 77 and a 78. And we'll just watch and make sure that these change. They will turn red when they change. Let's wait and see. There, they just got sent, and you saw the minute updated also to 57. This is 8:57 in the morning. This time clock is correct. This time clock has never been set, so right now it's saying it's 17 minutes after midnight, I guess. You can see our send and receives are working properly. The data that I'm sending over to number 12 is not changing anything over here because in number 12 those values are always being overwritten. I want to look at something else. Right now I'm not doing any checks to make sure that, that this is busy or not. I'm going to add in something here real quick. As you can see, I've added in new contacts on rungs 2 and 3, also on 4 and 5. This is the SC102, which is the port 3 ready flag. What I'm doing here is just trying to make sure that when you program that you always keep in mind that you don't want to have conflicting commands or conflicting information trying to be sent through a port at the same time. So with this in mind, I hope you've enjoyed this video. In the next video, we will be connecting in a couple of radios and adding in a couple more stations to the existing programs and hardware configuration that we already have. Thank you very much, and please like and subscribe.